Hello, fellow students. What's up? How's it going? How have we been? It's always good on this side of the grass. Well, I don't know if it's greener, but sure it looks greener. So, all right, so today we're going to deal with absolute values. Okay, so absolute values can be a little tricky because when you see these lines right here by the equal sign and in front of the X, those are absolute value symbols. So whenever you see those are like, oh, absolute value. Now you deal with these a little bit differently than you do, than you would any other type of math problem. You would actually do something a little bit different, but I'll show you once we get there. So how you approach these is you do them like any other PEMDAS problem. So you're going to add 3 to both sides, 7, 8, 9, 10, which is x is equal to 10, and that'll be it. See, you think you're done, but you're not. So with absolute values, we're judging the distance from 0. That's what we're doing. So I'll solve the other one, and then I'll show you on a number line to make things more clear. So you would actually write x minus 3 is equal to negative 7. And I'll explain how that works in a second. So you add 3 to get x by itself. Add 3. Actually, get rid of those absolute value signs. Get rid of those. Those don't exist right now. Plus 3 right there, 7. And then plus 3 right there. So 7, 6, 5, 4. So that will be x is equal to negative 4. All right, so let me show you on a number line how that would work. How absolute values work. Draw a quick one here. Quick little number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bad number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So our answers are 10. Put a 10 right there. And then negative 4. 1, 2, 3, 4. Negative 4. Okay. So what we're doing here is that we are trying to get 7 away from 0. So there are 2 ways you can get 7 away from 0. 1, 2, 3, 4, 5, 6, 7. Right there. And 1, 2, 3, 4, 5, 6, 7. Right there. So negative 7. So there are 2 ways you can get to 7. It's either a negative 7 or a positive 7. So our answers are 10 and 4. And we have a subtract 3 up here. Notice that if you subtract 3 on either side here, right here or here, you will get to 7. So that's why we have 2 possible answers, is because it can either be a negative 7 or a positive 7, because the absolute value of negative 7 is 7 anyways. So notice that between the negative 4 and the 10, if you subtract 3, you'll get to 7. So it's either 7 or negative 7. That's why there's 2 answers. That's why absolute value problems work this way, is because they're both 7 away from 0, basically. Okay, moving on. I hope that helped. So 3x plus 2 is equal to 10. So here's what we're going to do. I'm going to do 3x plus 2 is equal to 10. And then 3x plus 2 is equal to negative 10. All right, so here's what we do. We subtract 2. That'll be 3x is equal to 8. Divide by 3. Divide by 3. And we can leave it as that, as 8 over 3, because that is no way that's going to divide out evenly. And then we'll come over here and do the exact same thing. So we'll subtract 2, which is adding 2. So 3x is equal to negative 12. We divide by 3, which is negative 4. So x is equal to negative 4. Very good. Very, very good. So on a number line, if you add 2, you're either going to be at negative 10 or you're going to be at positive 10. They're both 10 away from 0. 10 away from 0. All right, here's where we get fun and tricky with things. Okay, so you would not go about doing this as a regular PEMDAS problem, because we have to have the absolute value by itself in order to completely get in order to get it by itself. In order to get x by itself, we have to do things a little bit differently. So here's what we're going to do. We're going to get everything on the outside of these lines right here out of the way. We'll get them out of the way. So we'll subtract 2, get rid of that, which would leave 5, oops, sorry about that, x minus 4 is equal to 20. And since 5 is would usually multiply out like that, but it's not going to, we're going to divide by 5. Get rid of it. Divide by 5. 5, 10, 15, 20. So we have x minus 4 is equal to 4. Okay? And then we add 4, which will leave us with x is equal to 8. And then we'll put another x down here because we're doing the negatives. Okay, so another tricky part, another very, very tricky part. So we have to do this the same way. So I'll write it out again. 5x minus 4 plus 2 is equal to negative 22. All right, so here's the trick. This is actually not correct. Since you simplified it down here, you would actually do it as x minus 4 is equal to negative 4. So you don't go back up to the top. Once you get it by itself the first time, you don't have to do it again. You can do it. You can get it to where it's by itself, and then just make this part right here negative. Okay? So we're going to add 4 there, add 4 there, which is, how about that? 0. 0. Excellent. All right, so not too incredibly tricky. It is just a little teeny tiny bit, but not too bad. Just remember, once you get it simplified, you don't have to do it again. You can just bring it over here and just throw that negative on that 4 that we solved earlier, and then you can just solve it from there. Okay, moving on. We have got 2x plus 6 minus 4 is equal to 22. Okay, so we'll solve it like we normally do. So remember, we want to get the absolute value by itself first. So we'll add 4, 26. So 2x plus 6 is equal to 26. I'm going to subtract 6 now, which is 20. 2x is equal to 20. We'll divide that bad boy out. 9. We have 9. I'm sorry, 10. I lied. Swoop. Sorry about that. X is equal to 10. 10. X is equal to 10. All right, we'll throw another x. All right, so if you remember from the last problem, we can go 2x plus 6 is equal to 26 initially. So negative 26. Negative 26. Okay, so we'll subtract 6, which is 2x is equal to 32, negative 32. We'll divide that out, which will leave us with a fantastic negative 16. Negative 16. Fantastic. A lot's come at you in this particular one, a little bit different, but that's kind of fun. So remember, when we have problems like these, make sure to get the absolute value part, the part in between the lines, by itself. Make sure you do the simplified version first in your negative version. I'll call it positive and negative versions. And then just make sure that your math is correct and that you're following PEMDAS. But other than that, thanks for listening, guys. I hope you had fun.